waiting time in front. And also we sent this week's update a little bit earlier this week. I sent it yesterday. Yep, yesterday I think. Normally I send a weekly update on Friday, but this time was a bit, on Wednesday night, sorry. Because we sent some updates that we think you might need that earlier, including we roll out a new module request for iteration 2, and also we give a recording on each, explaining on iteration 2. So I hope those can be helpful. And another thing important is that I will be overseas for 2 weeks in week 7 and 8, traveling for conference. But I will still be available online, monitoring the labs, the tutorials, and also the projects and everything. The only difference is that you cannot see my face in person in the lectures. And we will have a guest lecture in week 7 and 8, which will be Hayden. Not sure if you know Hayden, but Hayden had a couple of recordings on the project. And Hayden will do the lectures in week 7, 8. And those lectures, he will deliver those lectures remotely online, but we'll still put up the theater and project we do here. So you can still come in and enjoy the theater together with your friends, with your group team members. So yeah, so that's a few updates before we start the lecture today. So today, before Hayden take the guest lectures, I will start the lectures on design. So this will be our first lecture on design. So we have a couple of topics in this course, like coding together, development, project, crackness, full stack, and now this is our first lecture on design. And this lecture is about designing for maintainability. So before we explain what is maintainability, so let's start with a scenario. For example, now you are working on your project, okay? And you know what is in your project. You know the lines that you have written, and you know every function that you designed and you created. But what about now if a new team member joined your group and they will need to build on top of your functions, build on top of your projects, okay? Or what if one of your team members, due to some reason, for example, he's ill, and you will need to take over his functions or their functions? Or what about after this term, after 1 year, and then you found I want to continue work on this project. Maybe I want to add some features, I want some change some of the roles, want to make some changes. And you may encounter some difficulties when these scenarios, challenges when you encounter these scenarios. You still remember what is happening in your project now, but after 1 year or after a few months, how can we ensure that we can pick up this project quickly? And how can we ensure that when we have a new member join our software project and they can pick up on the functions quickly? Okay, so this is why we want to design our software project with maintainability in mind. Because our code is always changing. And not only our code is changing, but our people is changing. So for example, if you have a software company, you build a larger software in the future, okay, you may have people joining your team, maybe leaving your team, maybe your software is going to be used by a lot of people and you want to add new features to it, grow your software. So we want to make sure our software can be easy to update in the future. To incorporate all of these changes, change in people, change in software features, and all the other changes as well. Okay, so a quick recap of what is software engineering. So we introduced this definition in week 1. So software engineering is where we focus on building the right software for the right people and making sure it's maintainable over time as it grows and as the people who work on it change. So this is the definition of software engineering. So till now we've talked about how to develop software projects, and now we move on to the second part, like make sure it's maintainable over time as it grows and as people who work on it change. Okay, so let's come back to this software development life cycle again. Like we have seen this picture for a couple of times now. So one of the phase is called maintenance. So phase 6 is called maintenance. So this is what we are going to cover today about maintenance. So normally software maintenance is done after our software is launched. So after people start to use it, and we may receive some feedback from our customers, and they may tell us, well, we think this needs to be changed, or we want to see another feature. So we are maintaining it. Okay, and maybe there are also some bugs, like people review some bugs in our software, and we need to resolve those bugs. And we may also want to improve the system's overall performance, like security or users' experience, to improve our software. Okay. So before we move on to explain more details about maintenance, so let's do a quick activity. So if you are assigned to maintain a software that is not developed by you, so you joined a new team, and your job is to maintain this software. So what property do you want this software project to have? So your job is to, for example, fix some bugs of a software, add some new features to the software, but the code was not written originally by you. So what kind of feature do you want to see? Is this QR code active? Yeah. Readable code. Yes, that's a very good point. Clear variables. Yeah, you can easily know what they do. Yeah, exactly. Easy to read and understand. Yes. Easily updatable comments explaining the purpose of the functions. Yes. That's all very true. Yep. Consistent. What do you mean by consistent here? Yep. Anything else? Scalable. Use of constants and functions exactly, so changing things requires less work. Software. What is this one? Like software. Okay. Are we still getting more insights in? Well documented. Yes, that's also a very good point. Maintainable. Yep. Cool, great. I think, yeah, readable code. So we have a sum up on the readable code. So you can see the trend, like you mentioned, like readable, good variable name, documentation, comments, easy to understand, easily update, easy to read. So you can see the trend. Like if you are assigned to maintain a software, you know, like you want your code, you want this piece of code to easy to understand, right? Have comments, have documentations. Okay, so this is when you are maintaining other people's software. So your software may also need to have these features, right? So Yep, we have covered this one. Okay, before we look at more details on how we write maintainable code, all of these like general features are good. Like, yep, duplicate code. So this is also a very good one. Yeah, so you can see these are the like good habits of writing maintainable codes. And sometimes we may ignore some of these key properties when we're writing our software. For example, like comments, writing documentations. Most of the time, like we are pushing by some deadlines. So for example, deadline for iterations, deadline for like when you're working in industry, you also have deadlines. So we are always pushing by those deadlines. And we may we may want to prioritize writing like workable codes. Like your codes can pass all the tests, your code can have like a good performance, like speed and accuracy. So sometimes we may ignore the other important properties of writing codes. However, what we want to argue here is maintainability is sometimes more important than the performance. Because our software is growing, you want your software to grow, right? And if it grows, if it changes, we need to maintain it. And if you ignore like the maintainability of your code, when you make change to your software, you want to improve the performance. Sometimes you need to performance issue will appear when your software grows and when you are like fixing those bugs. Okay. So although writing like codes with maintainability, like comments, like documentation, at the beginning point, you may find like you are spending more time, but eventually you are saving time and writing better performance code. Another thing is who has written open source code? Great, amazing. So when you open sourced your code, did you consider like having other people to build on top of your code, like maybe add new features to your code, maybe even help you fix some of the bugs of your code? Yep, consider that.
Just keep joining me not use it, not next time very much.
Mm-hmm. Yeah. So in general, when we open source our software, we want to have people use our code. Right? So we open source it, and we want our open source code to grow. And this means that people will need to maintain your piece of code, like maintain your software, because they need to make change to your code. They need to use your code and read your code, build on top of your code. So this is when we want to open source our code. Like we need to consider the maintainability of our code. And even if you are not like planning to open source your code, like maybe you are writing a piece of code that is deposable, like you think I'm only going to use this function once for my project at the moment. I'm just going to ignore that in the future. And you may sometimes find that after a couple of months or years, like if you are still working on software engineering, and you think, I'm solving this problem now, and I think I have written a similar function before, and you cannot find where is it. Or if you still can find it, but you cannot read that anymore because you were attended to written deposable software instead of writing reusable software. Okay. So it's a very good habit when we writing codes or developing software. We want to make it reusable in the future, like maintainable in the future. So there are some key factors of maintainable software, and I think most of these features that you have already covered in that QR code, like when you respond to that QR code. Like first one is easy to understand the software, like how it works, what it does, and why it does the way it does, like having comments, having documentations, have clear variable names, right? So it helps the software to be easy to understand and easy to find what needs to be changed. So after you understand how it works, what it does, and then it helps you to identify what needs to be changed. And easy to make change, that you can easily build up like on top of that software and check that change have not introduced any new bugs. Okay, so now more specifically, but how? Like how do you write maintainable software to meet the criteria that you have just put in that QR code? How do we make software maintainable? So here's another one. Okay, think about the criteria that you just put in and how can you make sure that your software meet your criteria. For example, like readable, easy to understand, easy to read, read for other people, not yourself. Yeah, standing on other people's point. Yep. Linting. Yeah. Okay. Regular auto linting. Yep. Linting is really helpful for styles. Right? Use comments and good variable names. Clear commenting. Yep, comments, white space. I think one more is missing, like one important component is missing here. Anyone knows what is it? Let's see if we have that coming in. No. Yep, cool. This all makes sense, but there are more than that. Okay, testing. We have so far ignored testing. So we mentioned that we want to write testing first before we fill in the code block of that function, right? So when we make change to the function, the test should always be working. Right, so have good testing suits is one important way of writing maintainable software. Like when we maintain our software, when we fix our bugs, we do not want to introduce new issues, right? We want our testing still to be passed. So we want to have good testing. So verifying the correctness of your code, it becomes easier to make changes to it without worrying about like adding new errors or new bugs. So testing is important for maintainable software. And the second one is called system design, like planning ahead. Like before you writing any specific function, we plan ahead, like on a higher level, on a system level. Like what components we are going to have, like are we using HTTP protocols, like that. So higher level design. And the next one is called code design. So I think most of your comments are primarily focusing on this, like code design, which is nice. Like this is also what we are going to cover, like focus on today about maintainability. So code design, like think about code at a high level and low level details in terms of what makes things resilient and adaptable to changes in the future. And we'll be focusing on this code design for maintainability in this lecture. So code design is something happen in between writing your tests and writing your functions, writing your code. So after you write your test, like you have an overall idea about what you are going to write in your code, and then you write the specific code, like write the functions. It is when you know what solution is to do, like you have those tasks, you know the expected output, but need to plan how we achieve this expected output. And our tendency is not to write like well-designed code, like as we mentioned earlier, like we are always pushed by deadlines. So here we provide you with 6 questions to ask when you are writing maintainable code. Like when you, after you have written your tests and before you write down your code, you may ask yourself a few questions for better code design. So the first one is, don't repeat yourself. So this means same variables defined in multiple places, or some of the code, like a couple of lines, can be abstract into a function, and then you can call this function in the future so that you are not repeating very similar code again and again. So this is easy to forget. So if you have repeatable code here and there, and if when you want to change this block, you may want, sometimes it's very easy to forget some of the code. So for example, you change at one place but may forget to change in other places. But if we abstract it somewhere and then we only change it at once and make sure the change applies to all locations. Okay, so let's see one example to make it more clear. Dirty dries. 5. Okay, so here's our code. So can anyone help me clean up this code and try not to repeat ourselves? Any thoughts? Yeah.
You just turn the for loop into a function.
Turn this for loop into a function. Yeah. Okay. So yes, you may have noticed like this block, this for loop, and this for loop, they are very, very similar. Right. So before we turn this for loop into a function, let's have a look what this function does. To make it more clear that they are doing very similar things, I'm going to change that a little bit to avoid some confusion. Okay, so you have used argv in one of the labs before, right? No? Not yet? No, okay. So let's run this code and I will explain what argv is. Oops, clear. Oops. So npm run ts node rc 5.4 dry dirty.ts. So nothing was console logged, so we got nothing in the terminal. This is because in this line 3 to 5, in this if block, it checks how many inputs we have after npm run. And if it's not 3, then we just process exit. Okay, so now we only had like ts node, this is one argument, and ss is the file name is the second one. So we need to have 3. Okay, so now let's try have, for example, 3 or 2 after that. And you can see it runs the following blocks of code. So argv lines checks the lines of our arguments in terminal. So this is what it does. And then we assign the path in argv2 is the third variable. So the number like we gave in the terminal here. So number here will be equal to 2. Okay, but we can also have it 3, and then number will be 3. So taking inputs from terminal. So similar use as like we used the prompt sync before. like getting inputs from terminal. And argv is another way of doing that, get user inputs. Okay, and if number is 2, then we go through this for loop, and we console log I plus 2. And if number is 3, like the user's input is 3, and then we console log I plus 3 in the loop. If that makes sense. Okay, so now let's revise this code and avoid repeating ourselves, writing very similar for loops here. So let's define a function. What about we call it a math? Okay. So the input is only one variable, which is number, and we put this for loop in this math function. And 3, we need to use number to replace 3. Is that clear? Any questions so far? All good? Yeah. And then we can call this math function. Okay. Any questions so far? So we abstract this for loop in a function like we defined called math, and we call this function in the following code block. So now if we want to change the math that we want to do, we can simply change this math function. So we can change this plus into like times or other math functions that we want to change, so that we do not need to change once here, like twice. Yep, makes sense? Okay, so now what else we can do to make this code more maintainable and easy to read? What about people online? Yep. Two or three. Yep, that's a good point. So now we have if number equals to 2, then we do this math function. If else number equals to 3, we do this math function again. So it's still a kind of repetition, right? So we can simplify it by having if number equal to 3 or number equal to, if number equal to 2 or number equals to 3, and then we call this math function. And then now we can remove this else if block like that. Yep. Okay, anything else? Yep.
You can define all these tenants with this delta and
Sorry?
you replace the value with tenants with your constant delta and
Do you mind just come up here and change the code? Oh, camera, over there, camera. Oh, that one. This one, yeah. Const start, well. Yeah. Amazing. Thank you so much. I think this is a very good point. Like sometimes we may want to change the start value and end value, and it makes more sense and it's more clear. Like those two values are where we want to start and where we want to end. So we give this variable a name. So we give this value a variable that we assign to. And then in the future, we can simply change where we want to start and where we want to end. Yep. Anything else? Nope. Okay. Good. So last time we had students asking to define another function, and this function does process.exit1. So this is what they. So they define a function const exit function, and in this function, what they did was process exit1, put it here, right? Because here we have process exit1 and here again. So this said that we can avoid that repetition by using by call this exit function here and here. But not too much simplified, right? This might be good, but might not be good. We'll explain why. Okay, not now, but very soon. Okay, so now we have explained this very first question, like don't repeat yourself. Like ask yourself whether there's repetition in your code. So it doesn't mean that you cannot repeat yourself at all in your code. It doesn't mean that. The ultimate goal is to make sure your code is easy to read and easy to update. So sometimes if you repeat yourself once, it can be fine. But if you are repeating yourself too many times, maybe there's something that you need to do to avoid that. Okay, so the next one is keep it simple and stupid. So you may have seen like keys before, right? So keep it simple, stupid. Is it as simple as possible? So this is another question you want to ask yourself. We have students like I know very advanced in like programming and sometimes write very advanced functions. So this is good like for practice, for learning new ways of writing our code. But ultimately, again, like we want to write simple codes, like as less lines as possible. Because every line of code, like every piece of your code, you need to maintain it in the future. So if you can write your code, like write a function in 3 lines, you do not need to write like in 20 or 30 lines. So we want to keep it simple, stupid, so that it can be easier to maintain in the future. So every line of code you don't write is bug-free. Right? Yeah. So the more code we write, the more code we need to maintain, and more code we need to test. And this is called KISS principle. So the core idea is that a software system works best when things are kept simple. Okay. Let's try this example. You are assigned a task now to write a function to generate a random string with up to 50 characters that consists of lowercase and uppercase characters. How are you going to write this function? Generate random strings, up to 50 characters, lowercase and uppercase characters. Any thoughts? Sorry? Yes, exactly. That's true. That's absolutely right. This is also what I'm going to do. Find a package. And then we can use the functions in the package and then call that function in one line and solve our problem. Okay, so now let's have a try. Let's go to npm, search here packages. What about random string? Random string. So a couple of random strings. Let's have a look at this one. It's updated recently, and its weekly download is great. Like a lot of people are using it. Potentially it can be very reliable. So let's try that. We need to npm install this library, and then how do we use that? Okay, npm install random string. Let's do that. Npm install random string. Done. And then we can start generate random string. And here are some examples, like random string dot generate with no parameters inputs, and then give a random string with both numbers, characters, uppercase, lowercase, and just random lengths. More examples with only alphabets, like only characters A, B, C, D, and the length, like we can define our length here. So this is like we can call this function and help us generate a random string. Okay, random string. Where are you? Oh. Yep, here's our code. Okay, so this is the first example, write a random string. Let's do it in a quick way. We need to import this package first, right? Import random string from random string, and then we just copy and paste the examples here from the npm, like their README file, right? So they said that we can call random string generate, give it length, like let them know that we only want characters and do not need any numbers. So alphabets, and then we console log this string. So let's run it quickly. So npm run ts node. This file is called random string. Now we got a random string with the lines that we specified. So this is how we write simple code. If there's any library, any package that we can use directly, we do not need to write our own one, so that we do not need extra effort to maintain that, if that makes sense. Let's have a look at another example. Here's another task. Write a function that prints what day of the week it is today. How are you going to write this? npm again? Yeah, that's npm library, that's true. Yeah, so npm library, definitely we can use that. But sometimes there may be already like a JavaScript library we can use directly. Yeah, so you may want to check whether there's a like JavaScript library we can use. If not, we can like always check npm library. But here, in the pre-example, we have had a look at using npm library. And what about in this example, let's have a look at JavaScript library, like built-in libraries. What day of the week? So let's Google here. Oops, JavaScript. What day of the week today? So there's a function in JavaScript called getDay. So basically this function, what this function does is get the date of today. Let's try to copy and paste this example code. Const day, new date, let day equals to the.getDate, and then let's console log this day and play with that a little bit. Console log day. Okay, let's comment the previous one. 5. What is 5 here? It means the 5th day of the week, which is Friday. So this is how this getDay function works. But what we want is print out something like Monday, Tuesday, Wednesday, and now it should be Friday. Let's scroll down a little bit. Great, so here are more examples provided here. Like we can define a an array with strings of the weekdays, and then we get the 5th day of the weekday, and then we can console log Friday as what we expected. So let's copy and paste this example here, and then console log day. Let's try that again. Great, it's Friday now. So we can always leverage the libraries, like Node.js libraries, JavaScript libraries, and also NPM packages, so that we can have less lines and less code to maintain, instead of writing everything from scratch overall. So this is also another very powerful feature of JavaScript. Right? So we have a very strong code base that we can build on top of, like the NPM libraries and also JavaScript building libraries. So this is, and the third question we want to ask is this over-designed or under-designed? So in the very first example, like we console log 10 plus 2 or 10 plus 3 in a loop. We try, so not you, but I myself, I define a function called exit function, and I abstract this process.exit1. However, this is not actually a very good practice. So I did something like over-design, so what we call over-design. Why? It's because in as a software, like when you work in a team for a while, you may notice that people are always using process.exit, or 1 or 0, so they know what you are doing. So when they see process.exit, they know that you are exit, like you are terminating your code or function. But if I define another function called exit function, and this function's name is given by myself, so they may need to look up and find this function and check what is in this function, so they can understand what you are trying to do here. But instead, if we just have process.exit1, like in general, as a convention, people know what you are doing, so that they do not need to check what is in this exit function to understand your code. So this is somehow I have over-designed this piece of code. Well, under-design, so over-design sometimes can introduce additional challenge for yourself and also your team members for maintain this software in the future. However, another tendency is we may have under-designed code. Like the original code, like we have seen before, like before we had this math function, and we had a for loop here and there. So where can we find this balance? Like how can we know if we have over-designed or under-designed? It takes time. So the tendency is, as a young programmer, like software engineer, we may start from writing under-designed code at like beginning, and then when we are more mature, we start to like put more emphasis on designing our code, like have better design code, and we may grow into like have an over-designed code. And then when you are even more mature, like more senior, you can find this balance in the middle. Like you know where we should abstract, where we should put more emphasis on designing our code, and where we just can leave it alone, leave it like what it is. So this is like when we use examples in like code design, but in general, in engineering, in software engineering in general, we may also sometimes have over-designed or under-designed, like not only in code design, but in a more broader sense. So here I found a very interesting example of over-design. Like this is what the design team start with. Like they want to build a rock machine, and they want to help this person from here and jump higher to the sky, to the outer space. And then they want to like, oh, I think we have make it too complex. Let's simplify it, and this is what they what they settle for lunch, like this. However, what the user actually need is simply a bag with a wrap. All right, so we want to make things good. Like we want to get better code. We want to get better software, but sometimes we may have over-designed our software. Well, over-design is good. Like for your customer, they thought, well, you spent time on my project, you put your effort in my project, so this is good. However, sometimes it may waste energy, waste resources, waste time where it's unnecessary. So when we want to design a better code, design a better software, we may want to ask yourself a question: is this necessary? Okay, if it's necessary, we do it, of course. But if it's unnecessary, we may want to consider whether we want to put this emphasis on it. However, over-design is better than under-design. So under-design, so if your client came to you and asked for software, but this software is under-designed, meaning that it doesn't achieve the performance that asked by the client, it doesn't secure, it's not safe, so it will ruin your reputation as a software engineer, as a software company. Yeah. Now here are the fourth and fifth question that you may want to ask when you design your code. Are related modules kept close together, and are unrelated modules kept far away? So here are two concepts for each of 4 and 5. The first one is called coupling. So the coupling of your software or your code refers to the degree of interdependence between software modules. And good software will have low coupling. So this means we want to have the different modules of your software have less dependencies. So when you change one of the modules, do you also need to change another module? Right, so you do not want that to happen, right? So you want to have different modules or different functions or different group of your code are independent from each other. So that when you modify, when you change one module, one part of your software, you do not need to update another piece of your software. So this is coupling. We want to have low coupling. And the cohesion refers to the degree which elements within a module works together to fulfill a single, well-defined purpose. And a good software design will have high cohesion. Means that related components are kept close to each other. So you can easily find the relevant code or relevant function. So they are kept close to each other. And this group of code will fulfill a small single purpose instead of putting a lot of functions, a lot of code together and fulfill a very large purpose. Okay. Spaghetti code. So you may see spaghetti code sometimes in some libraries or packages. So spaghetti code means have excessive coupling. Like the different pieces of the software depends on each other. So when you go to, for example, go to here, go to here, go to there. So a lot of pieces of code you need to go to understand your purpose. So sometimes you may want to have less dependencies between your different code modules. So it can be easier to maintain. you aren't gonna need it. So this happens a lot, especially to myself. So I made this mistake quite often. So when I started as a software engineer, I wanted to write good code. I want my software to have good performance. So when I started on a task, I think, well, I will need to have this feature, I will need to have that function, I will need to have this and that. And eventually I found that some of the function is never called, some of the features is never used, and I need to maintain those unnecessary piece of code. So some of those can be unnecessary. So a good solution to this is to have a top-down thinking. Means that you start from your purpose. So what is your end goal? And then get from this end goal, go through top-down thinking, and make sure that only you write functions or features that you will need. And this helps remove unnecessary code and therefore result in having less to maintain. One interesting example here is that I have been working with a student on a project. And this project was helping tutors to provide good feedback to our students. And when I was discussing this software with that student, and the students are like, I'm going to have a login function first. I know how to design this function, and I think it's necessary. I'm going to do this first. However, is this the core value of this piece of software? We know from the beginning that login is necessary or not? The answer is no. So the core purpose of this software is to help tutors provide good quality feedback, right? So help tutors provide good quality feedback. So improve the quality of feedback is the core purpose. So from top-down thinking, we start from the end goal. And then after we had that feature to improve tutors' feedback quality, so when we achieve this feature, and then we can come back and rethink if we really need tutors to log in to use our software, right? The next one, okay, so this is the last question. So the last question you may want to ask yourself is, does this follow standard conventions? So this go back to our example here again. So process.exit is the convention that we normally use, and people like other software engineers understand what process exit is, but they may not understand what an exit function is. So we want to follow the conventions. Other examples, so when you are writing like a web server, you are building a web server, should we use JavaScript, should we use C, or what should we use? So we follow the conventions. Other people are using JavaScript, other people are using Python, and then we'll use that. But you will not consider using C to build your web server, right? So this is another example of convention. Other examples include like uppercase constant, like how we name our variables, how we choose the libraries, the packages. Here are a list of some common standard conventions. For example, comment conventions, how we leave comments. Indent style convention, like style conventions. Line conventions. So when you write a very long line in your code, is there anything wrong? I don't think it's wrong, but it's not the good convention. It's not good writing like your code. It's not good style. And also naming conventions, programming style conventions. So these are conventions that we want to follow when we write maintainable code. Before we wrap up this lecture, another thing that you will hear is called refactoring. So after we launch our software, when people are starting to use our software, it doesn't mean that our code design process is done, right? So before refactoring, like when we mentioned earlier, like when we ask those questions, when we think about code design, that code design happens when you write your test and before you write that function or write that code block, right? But refactoring is after everything has been written. You may still want to improve your code design. because no one writes perfect software in the first time. And refactoring is the process of reconstructing existing code without changing its external behavior. Like we only change what is in the code block, like, for example, in the function, but do not change its external behavior. So here's I provided like a link to an online catalog of refactoring and some interesting ones. For example, in refactoring, you may want to rename some variables. For example, here originally you may have let A equals to have NWest, and now you may want to change A to area. So this is one example. Other examples, extract functions. Okay, so this is what we did with the first example. So you may want to extract some of the functions after you have building your software, and remove that code. Okay, so this also happens a lot. So you may have changed your code from one sprint to another sprint, or from one iteration to another iteration. And some of the code you may notice that you are not using that anymore. And then you still need to have tests for like unused code. You still need to maintain those unused code. So you may want to remove that code during refactoring. There are other examples that you can have a look, like how we refactor of a code. Okay, otherwise that's everything about maintainability here in this lecture. Yep, have a break. Come back in 3 or 4 minutes at 12:05, and we'll move on to the next lecture about design. Feedback. If you have any feedback about the lecture, about the code, like about the course, let us know. And now it's week 5. If you have any feedback for us to improve, we still have time. Otherwise, if we receive your feedback in like week 8, week 10, or if after the course is done this term, we can improve for future students, but not your cohort. So if there's anything that you want to see us to improve, let us know, and we still have time to give you a better experience in this course. Okay, thank you. Have a break.